let's understand what a remap is and what we are trying to achieve. So here we have a visualization of a scale from 0 to 1 on both axes. What does that mean is that we have here 3 little dots, and all of these dots represents a coordinate. And here you can see this dot represents 0, 0, here 0.5, 0.5, and here 1, 1. So what we are trying to do here with a remap range is that if we scale this, we should now get new coordinates for each point. So this point now is located at -1, -1, as opposed to 0, 0. And that's true for all of the other points as well. So here is 0, 0, and this is the new mapped range on 1, 1. Right, so let's see how that applies for Godot script first. Let's get a set of values here. So here we have a 0.5 that goes from 0 to 1, and -1 is the target, and target max is 1. So essentially, if we go back here, so we are trying to mimic this dot here, 0.5, 0.5. So if when we remap, we get 0, 0, that means it's working. So how do we do that? For that, we have a Godot built-in implementation, which is this one. So for this, we can see that if we hit play, we should get 0. So here what we are doing is that 0.5, starting from 0 to 1, needs to be remapped to -1 to 1. Okay, so this is the Godot built-in implementation. But then, if you search in the internet, you should find something similar to this. So this other function is what you see in the internet if you search for map range or range Lerp or something along those lines. So if we now try to run this, you can see here, let's hit play, so we get the same value here. So this is just another way to understand what's happening when we run this Godot built-in implementation. What we can also do is to implement a custom remap function. So this custom remap function should give us a hardcode remap function. Let's see how it works. So if you play here, you can see that this function remaps all of these calculations out of here and out of here, and translates to a single operation, simple equation. So let's try that. So if we replace the value and times 2 -1, as in here, we should be able to see a hardcoded version of all of those. So if you now hit play, you see the hardcoded is also 0. So here we have the first range Lerp. So this is Godot. So this is what you find in the internet, and this is a custom one that gives us the option to hardcode this. What does that mean? So let's get an example here. So let's say we have a different set of values. So let's say now, so instead let's start with 10. So let's say that we have a value 10 where it ranges from 0 to 10. So it's pretty straightforward. But now what we want back from this function is that it remaps from 10 to 0. What does that mean? That means that where we have 0, it should come out 10, and where we have 10, it should come out 0, and everything in between. So we are sort of reversing. So now if we hit play, we inserted 10 and got 0 out of this. And the hard-coded function now is different. So we need to replace with the new hard-coded version of it, which is times minus 1 plus 10. So if we now hit play, you see all of them match. So if we get 2, the reverse of 2 in a scale 10 to 0 is 8. So here we have it, number 8. So this is on a float value, so it's you can call it one dimension. So let's see how we can do this in 2 dimensions. So here in 2 dimensions, you can see that we are doing the same thing, except the value type now is vector2 with 2 different ranges. One thing here is that the good old Lerp implementation only works for float. So we can't use this. So that's the reason that we have all of these other options here. So with the map range, so now if we replace everything for the vector2, we should be able to replicate the same thing. So let's see how that works. You can see here we have the same configurations, 0.5, 0.5 now, and 0, 0 to 1, minus 1 to 1, which is exactly what we did here. And the result out of this is 0, 0. So this one matches this one, which means it's correct. So how do we do to print it in a hard-coded way? So here we have the hard-coded, meaning it's the value, times the vector2 plus the vector2 minus 1 minus 1. So if we hit play now, here we have the hard-coded version, so we can skip all of these calculations here. So this one is the same thing as this one. Why this doesn't work here? So if we were to play this, it would give us an error. Why is that? Because Godot script does not translate this scalar or numbers to vectors. When we are doing multiplications, it works, but when we are trying to subtract or add, it does not convert it to a vector2, which this works is for shaders. So in shaders, it does convert these automatically. So that's why we can use this short notation for shaders and not for Godot script. And now if we change from a proportional one to a non-proportional one, it should work exactly the same, except that we can't use a short notation. We would need to come here and change it to minus 1 and 0. So when we are doing this on shaders, we will not be able to use this. We will only be able to use this when we have the same components here. Let's see how this non-proportional one works. So the hard-coded version would be this and this. So now if I hit play for a non-proportional one, I should see here the same values for hard-coded. So let's see how this one applies in a 3D. So if we just change all of these values to a 3D, we have the 3D vector. So if we hit play now, so this one is not hard-coded, we can just see that it works exactly the same. And then if you were to remap, we're going to change this to vector 3 plus a vector 3 minus 1 minus 1 minus 1. Again, if we were doing shaders, so hard-coded shader, we could replace all of this by a single element, single component. So that's how you do, and that's how you're gonna see the same thing on shaders, the shorthanded version. Now if we were to hit play again, you see the hard-coded version works as well. So let's see how this one apply in a shader. So if we come here, let's disable the visualization and let's open a remap use case. So from here you can see that I have this is the texture. So the texture is this big, ranging from -1 to 1, 0, 1. You could think of this as multiple versions. So I could have a image here that is a door, and here it's a pattern, here's a window, so on and so forth. So what I can do here, I can reduce the image to get only this portion here, so exactly 0.5. I can get this square here, and if I were to move it around, you can see that I can set it to go right there and right here. Let's get it correctly. What does this mean? So this means that I'm getting only this square. So let's say that this is what I want to remap. So let's include this one here again. And here we go. Here we have it. So what is it doing? So you can see here, just for illustration purposes, I have this remap, the same remap function here. And here I'm remapping the UV with all of these. So UV is the value. And here we are ranging from 0 to 1, and I'm giving it a square, which is this here, so x and y, so 0.5, 0.5, and the square size. So let's make it easier. So let's use our hardcode function to get rid of this remap function here. So if I go to the script, and let's change here to match the exact same one. So what we have here is a vector 2. So the UV doesn't really matter the value for now. Here we are saying that we are going to start from 0, 0. So here we have it. We can even make it float, doesn't really matter. And then the max value is going to be 1.0. It's also a vector 2. 1.0, 1.0, and we're gonna remap it from where it is 0. We're gonna remap it to the square. The square now we set it to 0.5. So let's make it 0.5. So it's a vector 2, 0.5 to 0.5 x and y, and then we are remapping it to the square plus the square size. So let's make it clear what we're doing. So the square is 0.5, and then we are adding vector 2 square size 0.2, 0.5. So this is what we're doing. So all of this is the same as 1. So let's just put 1 here to make it simple. And then let's hide this and let's see what it outputs. So here you see replace remap by value times 0.5 plus 0.5. So if we come here back to the shader, let's open the shader again, shall we? So if we come here, let's hide this. and let's say UV, it's going to be equal to UV times 0.5 plus 0.5 as suggested by our remap function. So what the shader is going to do here, it's going to convert this 0.5 number into a vector 0.5, 0.5. So this is going to be translated here and here. So this comes out of the box with shaders. And now you can see here that it's back in it's working. You can see here that it's working. So what does that mean? I don't need this anymore. I don't need the function. And just to make it even clearer, I can remove the parameters out of this one, because I'm not using the parameters for anything else. So the shader just works. I hope this makes it clearer how to use the remap and how this can be applied in the shader. Thank you.